when I'm simplifying trig equations, I want to look for my identities first, and then if I get stuck on that, I'm going to write things in terms of sine and cosine. So if I don't see an identity, then I'll keep going and write in terms of sine and cosine. So I know that 1 plus cotangent squared theta is one of our identities. So instead of writing 1 plus cotangent squared theta, I'm going to write cosecant squared theta. And I also know that there's an identity that's 1 plus tangent squared theta. And that's equal to secant squared theta. So when I see this secant squared theta minus 1, if I subtract 1 from this side, I actually have that this part right here is equal to tangent squared theta. So now I can use the definition of cosecant squared theta is 1 over sine squared theta. And tangent squared theta we know is sine squared theta over cosine squared theta. So what happens is I'm going to have these sine squared, they're going to cancel out, and I'm left with 1 over cosine squared theta, and I really could simplify this further because we know that the reciprocal of cosine is the secant, so this ends up being secant squared theta. Which this ends up being much simpler than this. So there's different ways that you could approach this. Some people would approach it as turning all of these into sine and cosine, maybe foiling it out and start knocking things out. Try to look for the trig identities, or the Pythagorean identities, I should say, first. So number 10, I don't really see any Pythagorean identities such as cosine squared theta plus sine squared theta equals 1, or 1 plus tangent squared theta equals secant squared theta. But I can just write secant theta as 1 over sine, or 1 over cosine theta. And I can just write cotangent as cosine theta over sine theta. And then these two cancel out, and I have a much simpler 1 over sine theta because this turns into cosecant theta. These two are reciprocals. Okay, the next one. So to write this simpler, this looks like a Pythagorean identity. So I have 1 plus tangent squared theta equals secant squared theta. So if I subtract secant squared theta from here, and I subtract tangent from here, I'm left with negative tangent squared theta, which is simpler because it's one term. Okay, number 12. I don't see any Pythagorean identities. So what I'm going to do is I'm going to take secant and write it as 1 over cosine. And I'm going to take tangent and write it as sine over cosine. So remember, when you divide fractions, you're going to invert and multiply. So you're going to multiply by the reciprocal of the denominator. So this turns into 1 over cosine of theta times, I'm going to flip these two around, so it's cosine of theta over sine of theta. So these two cosines cancel out. So I'm left with 1 over the sine of theta, which the 1 over sine of theta is the same thing as cosecant of theta, which is simpler than what we started out with. Okay, number 13. I'm going to write all of these in terms of sine and cosine. So secant of theta is 1 over cosine theta. Tangent of theta is sine of theta over cosine of theta. And cosecant of theta is the same thing as 1 over sine of theta. So what I can cross out is the sines will cancel out, and I'm left with 1 over cosine squared theta, which cosine squared theta, the reciprocal of that is the secant squared theta. So this is my final answer. And then 14 is, I'm adding these, so I'm going to want to get a common denominator here. So first I'm going to write everything in terms of sine and cosine. So I have sine of theta over cosecant of theta is 1 over sine of theta plus cosine of theta, and secant is 1 over cosine theta. So if I flip this second one over, if I flip the fraction over and multiply, I'm going to have sine of theta times, flip this around, sine of theta over 1. So this turns into sine squared theta. And then I'm going to multiply this side by, or this by cosine theta over 1 in order to cancel this out. So I'm going to get plus, this is going to be cosine squared theta. So sine squared theta plus cosine squared theta equals 1 is my answer. Much simpler than what we started out with.